Okay, so what we're going to be looking at now is that we're going to be looking at the last section in this chapter about applications of derivatives, and what we're going to be looking at is the antiderivative, which is, it's the anti of a derivative. Anti means the opposite or different, like antimatter, and all the other things like anti-social and everything else. It's got the word anti in front of it. It's the opposite, so we're kind of going in a different direction than what we usually do for a derivative. So if we have a function, let's say capital F of x is the antiderivative of f of x on a to b if the derivative of capital F of x is f of x. Okay, so basically what it means is that if capital F of x is 1/3 x cubed, if we were to take the derivative of that, that is your f of x, or your normal function. And see, what we're going to be doing is that we're going to be taking this function, we're going to be saying, okay, here's our original, and we're going to go backwards. So we're kind of going to swim upriver instead of swim downriver. How we've been doing is we've been taking polynomials that are like a 5th degree and breaking it down to a 4th degree and then a 3rd. Now we're going to go from like a 3rd degree and go up to a 4th degree polynomial. So we're kind of going backwards on these, and there's some different things that we're doing. So the first thing is why. Why, oh why, oh why would we want to do this stuff? And the main reason is to, if we're given a function that we know the slope of, because it is that function, so we know the slope at every point, we can go back and we can backpedal and say this is what it would originally be. When it was here, this is what it is. So by taking the the position, velocity, acceleration model, if we know what your velocity is at any given point, we can use an antiderivative to find your position at any given point. So like here, if we want to take the antiderivative of this, it would be it'd be t to the 3rd plus 3/2 t squared minus t, and then plus c. C. And that c is very important. Okay. And so by us going backwards, we're able to identify, okay, this is your position. This would be the function in which you're doing it. So if you know what your marginal cost is of something, you can go back and say this is what the cost is at any given point. And so it's very important for us to be able to do this. And then next chapter, when we get into more integrals, we're going to be using this some more. So the general antiderivative. So general antiderivative is that plus c at the end. So once you find the antiderivative, you throw on this little plus c at the end. And when you put this plus c on the end, it basically means that we don't know where this function is exactly along the y-axis, but we know this is what it will look like. Because when we find our derivatives, what we're looking at is we're looking at the slope of it. So we know the shape of it, but we don't know where it starts. And so that's what this plus c is. We could have this function almost anywhere along the y-axis. And if we're not given the starting point, like saying, oh, this is where it is, the original one is at this location, then we have to say, okay, in general, this is what it is, and then we have to find what the c is. But if you're just given a general antiderivative, they just want what's the antiderivative of this, you're going to want to make sure you put plus c at the end. Okay? Because again, we don't know where it is exactly. Now, the indefinite integral. So the indefinite integral is kind of the backbone of the next chapter we're going into, and this is where we're kind of introducing it. And so this little sign right here is called the integral sign. It's kind of like an F without the line through it. And basically, if you ever see that, you're going to take the antiderivative of whatever it's attached to. So the integral of f of x, or the indefinite integral of f of x dx, would be capital F of x plus c. Okay, and again, that means that the derivative of capital F of x is f of x. Okay, so what we're doing is whenever you see these integrals, you're going to be taking the antiderivative of them. All right, now the power rule. So the power rule for integrals, basically, what it is that if you're taking something to a power, so if I take the integral of x to the 2nd power dx, so the integral of x squared dx, what you're going to have is you're going to have x, and then you're going to go 2 plus 1 all over 2 plus 1. plus c. And then you simplify. This would be x cubed all over 3 plus c. Right. And again, we can't do this with -1 because remember, to get -1, we take the natural log. If the derivative of natural log of x, the derivative of that is 1 over x, which is x to the -1. And so we can't use this rule if n is -1. If it is, then we go back to natural log. But anyway, if you look back at here, where we found our antiderivative of this one using the power rule, okay, to check it, you just take the derivative. If you take the derivative of this, you would drop the power, so it would be 3x squared all over 3, and then plus 0. That cancels, leaving you with x squared. And we're back to our original. Okay. So a way to always check to see if your integrals are correct is to take the derivative of it. If you take the derivative of it and you get back to your original, then you got it right. Okay? 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 All right. Some other rules. If you have multiple things being added, integral of two different things being added together, you can break it up and you take the integral of everything separately with the adding or subtracting in between. If you're multiplying by a constant into a number, then you can kick that constant out front of the integral and you don't have to worry about it. You just multiply it in at the end of it. Okay. And so these are just some rules that will follow. It's just, like derivatives. When we did our derivative rules, it's the same thing, but now we're using it for the integral instead of the derivative. We're going backwards. All right, so here, if we want to take the integral of 3x to the 4th minus 5x to the 2/3 plus x to the -3. So we can take the integral of everything separate, okay, which will be the next one. As you see, we take the integral of everything separately. Now, when we do the power rule, the first one will be 3x to the 4 plus 1 all over 4 plus 1. Which means our very first one would be 3x5 all over 5. So there's our very first one using the power rule. And now the next one would be, when we take it, which we'll do this one in green, it would be 5x 2/3 plus 1 all over 2/3 plus 1, which would be 5x to the 5/3 all over 5/3. And when that cancels, what happens is if you simplify this, you get 3x to the 5/3. Okay. And now the last one, which we'll do in orange. So it'll be x -3 plus 1 all over -3 plus 1, which would be x to the -2 all over -2. And now we take all these and we plug them in. So the first one we would have, so our answer would be 3x5 all over 5 minus, because it's a subtraction here, 3x 5 over 3. And then it would be a minus, because we have a subtraction here, a minus x to the -2 all over 2. And that's it. And we just found the antiderivative, or the integral, of this function. And we're like, yeah, take that. Okay. Oh, and we forgot to go plus c. Always put the plus c. If you don't put the plus c, then it's wrong. So, yeah. I guess we didn't have it perfectly right the first time through. But we got it the second time once we got it a little bit fixed. All right. Now let's look at this one. So we're going to take the integral of everything separate. Okay. This would be x to the -2, 5x to the -2. The integral of that, which would be 5x to the -2 plus 1 all over -2 plus 1, which would be a -1 on the bottom with 5x to the -1, which would be a -5x -1. Okay, so there's our first one. And now when we do it with the second one, we'll have -3x to the -10 plus 1 all over -10 plus 1, which would be a -3x to the -9 all over -9. That reduces down to x -9 all over 3. And then we're going to add those, so we have -5 x to the -1 plus x to the -9 all over 3 plus c. And there would be our antiderivative, or our integral. Easy. Look at that. Boom. 2 in a row. All right, here are some of your trig integrals that you're going to have to know. Okay, you're going to have to remember these. So the integral of sine is negative cosine plus c. The integral of cosine is sine plus c. Secant squared is tangent. And so as you see, it's just the opposite derivative going backwards. Okay. The derivative of tangent is secant squared. So the integral of secant squared is tangent. Okay. So these are ones that you're going to have to remember and you're going to have to be able to use. Okay. Here are some more. Okay. So this is if we have stuff being added and subtracted inside the cosine. So it's basically kind of a reverse chain rule in effect here. And so if you have like kx plus b, what you would multiply inside would be, or on the outside would be 1 over whatever the derivative is of the inside. And so the derivative of the inside here would be k. Yeah, and then you add your c. Okay, so those are just a couple of others that we'll be using. So initial conditions. So initial conditions, this is where you will not have the plus c. So if originally you're given blah, 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 the antiderivative of this is blah, 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 plus c, okay, this right here, the initial condition, gets rid of that c. Okay, it changes it into a number. And so what you'll do is, again, we will take our antiderivative of this. So it would be 4 x7 plus 1 all over 7 plus 1. Which would be 4x8 all over 8, which reduces down to x8 over 2 plus c. Okay. And now it says our initial condition is that when y is 0 is 4. So when we plug in a 0 in for the x, 0, 8 all over 2 plus c, that must equal 4, which means c must equal 4. And now we take this and we plug it in there. So our final answer, f of x, or y of x, is equal to x to the 8th over 2 plus 4. And we are donezo with that one. So your initial condition basically says, okay, this is what it is. This is what the original one is at a given point. Now, find the original equation. So then you plug in whatever they tell you is the x value, set it equal to whatever they tell you that initial condition is equal to, and solve for c. And then you just plug it in, and then you're all good. And then we're all good. And then we get our answers, and we're like, yeah, that's what we do here. That's how we rock and roll. See? Boom. Done. All right. Here we go. So now we've got another initial condition. When y is 2, it's 2, and our derivative here is that we have sine of pi t. So we got to take the antiderivative of it, or the integral of it. And so the integral of sine, which if you remember going back, right here, integral of sine gets you back to negative cosine plus c. Okay. So we're going to have negative cosine of whatever the inside is, pi over t, plus c. But we've got to take, okay, what was the derivative of the inside? And we've got to divide it by the integral of the inside, or the derivative of the inside. The derivative of the inside would just be pi. So we're dividing it by pi plus c. Now, we take our 2 and we plug that 2 in there for the t right here. Oh, this should be d of t. So we plug the 2 in for there. So we've got negative cosine of 2 pi all over pi plus c is equal to 2. Well, what is the cosine of 2 pi? Let's see here. That would be a full circle. Cosine is the x value. The x value at 0 is 1. So that means we would have 1 over pi, negative 1 over pi, plus c is equal to 2. So that means c must equal, when we solve for c, we get 2 plus 1 over pi. And then we take that 2 plus 1 over pi and plug it in for that c. And so our final answer, looks like it'll be negative cosine of 2 pi all over pi plus 2 plus 1 over pi. And that would be your answer. And then we're done. Yep. See, antiderivatives are fun and easy. And they're fun to have. Okay, here's what your work is. So, for tomorrow when you come into class, what you're going to do is you're going to do your IRAT, which is your Individual Readiness Assurance Test. So there are 4 problems here. You're going to have to do all 4 of them, hopefully correctly. If you still have questions, we'll answer some of them in class. So here's the 4 that you're going to do. So the first 2, you're going to find the indefinite integral. So these are your general term integrals. So they're going to have the plus C on them. I'm telling you a secret that you should listen to. Anyway, the next one, you're going to take your antiderivative and then you have your initial condition. So I tell you what the initial condition is. So these, you're not going to have a C. You're going to have an actual number in for C. And then that's your answer. Okay? Sounds good? Okay. So, hope this helped. And we can be moving on.